All right. Good afternoon, everyone. Happy to be here. I'm here at BE Networks. I was thinking about it. Sometimes it's tough to be toward the end tail of presentations. You heard everything. You heard, and it's, very difficult to keep you interested. However, great questions like from Paul. So thanks for the setup. So with me, I have Luke and Greg. The next 20 minutes we'll take you through. So enabling Gen AI. You heard everything about the AI. Why not? Try not to bore you. I actually deleted some slides, so we have more times the real demo. So you'll be able to see with the typos, when you type the LLM and all of that. So enabling Gen AI, that's what we want to do and help a lot of our customers. But I believe, and I have sometimes the hard work to tell people that in order to truly enable Gen AI, humans are not enough. So in order to really bring AI to the next level, you have to use AI to manage networks. So it's almost like here in the beginning of the 19th century, tell all these network operators, hey, all you plug all those things, in a few years, they're all going to be disappeared, and it will be switches and today. So, our friends at Microsoft, they acquired MetaSwitch, so they know all about that. So you need to utilize real data and local resources, Paul. So that's why you asked earlier, you need to understand your network. And the only way to do it is to be the network source of truth. You have to know everything that's going on in order to do this. To have an industry data to tell you something about your network, interesting, not enough. So, which brings me to, experience maturity matters. And for large scale and real-time networks, you have to do it for a while. You cannot Python your script away out of this, and it's not kind of code and code and code. All of these Terraform guys, Ansible, I'm already hated. Usually, I'm not going to share what I think about infrastructure as a code, but I don't want to get into fights here. So for my 3-year-old son, this is a hyperbike. For him, you should see the sounds he make that. But it's truly Gen AI to make it. This is a well-oiled machine that needs to know everything. So the engineers that did that did a little bit work than this tricycle. So you heard all about SONiC and Ethernet fabric, and there were great teams here talking about the traffic, entropy, all this lossless, RoC v2. We are big supporters of the SONiC and everything. So we take part in all the different committees, and we, what Taras was talking, and PL Vision and others. There's great things going on into that. And we partnered with Dell. And there were a few papers that came out, and how Dell as the AI factory, bring you all together and hosting all of that. So with that, what we want to do today is actually 2 things. One, share with you, scale out, and how you automate, the hyper-automation. We believe, like I said, that you need tools to bring you to the next level. So one of the things we've been doing now for many years, we have a few hundred customers, not as big as this Project Kilo, which has close to 700 switches. But we learned a lot. And everything has standards until they come to the field and nothing works. So SONiC and a big switch, we just had deployment that if it doesn't come in a certain order, they kill the trunk. And depends where you sit on that, you might be in trouble, because if your VMs are in band, you cannot get to it. So everything is standards. Open committee is great until it comes to real life, and then you realize, well, it's not exactly. So Project Kilo that I have Luke here to give you a demo. Basically, we tried to get into 32,000 GPUs. In order to do that, close to a little bit shy of 4,200 hosts, Dell XE9680. And you can see a spine and leaf. Now, for all of you guys, yes, different architecture, but if you need to get there, this kind of scale, it's very hard to do it in a rail. So there's still development of what the right, here we have the 2 hops, so some latency, but in order to get to that. So with that, I'll give to my colleague here, Luke.
Thanks, Amir. So what we have here is, oh, it's not showing that. Okay, how do we do that?
Probably end the presentation.
Yeah, that's what it looks like. There we go. So what we're seeing here is a typical cross fabric. You've got 2 super spines that are connecting to 10 different pods. Inside of each of these pods that you see here, there are 2 spines, and then those spines are connected to about 60 leafs or so in each one. And so the way our product works, if we double click, we can then zoom in to each one of these pods and start to get more details and more information on these. And so for one thing that we like to show is we have the capability of showing the devices and all the interface connections that are based into this. Now, one thing that I can do from this is I can actually go in and pull up a report on this switch to tell me what exactly the interfaces are configured for. And from my report that I have here, you can see that I have multiple interfaces on here labeled for GPU NIC capabilities. So what I can do from this is I can actually filter what I want to show from this, and I'll just do a typical wildcard search for GP NIC. And that helps if I type it in there, GP NIC. And then once I filter this result, it's only going to show me my switches that need to have the NIC that are labeled for my NICs. I can then take this report, and I can then easily assign my profile to configure these interfaces to use my GPU profile. So from here, once I select all of them, I can then go into my actions and say, all right, let's go ahead and set my profile for this. And I'm going to tell it to go ahead and use my GPU for pharma on VLAN 501, hit accept. And now we will see it's now in the process of provisioning this. If I go back to my view and go back to my topology view, you'll see my background here is showing it as green. That's letting me know that the system is now actually pushing this configuration change down through. Now, another thing that we can do while it's doing this.
Sorry to interrupt. So I forgot to mention, this is the real simulator for our orchestration. It doesn't know there's a simulated hardware. Obviously, we didn't make a Dell's quarter and buy all those switches. But this is for the orchestration. It's real. We had to build a simulator, and I think there was discussion here with Keystone earlier about simulation, emulation. Totally agree. We don't have the money to buy all that hardware or those GPUs for this matter. So as we grow to GPU, but for our orchestration, that is the real network.
No, it's so long.
Yeah. Somebody plugged the cable out there. I can't. Some of the competition plugged out the cable.
No, that would be a poor architecture.
Yeah, yeah.
All right. My laptop just turned off.
Dell.
There we go. Bryce.
Yeah. Is it charged?
Yeah, it was. No. Battery's
All right.
low.
You see? Apple to the rescue.
Apple to the rescue.
Do you want a fifth charger?
Battery when I came up here. I do.
Thank you. Dorado to rescue.
It should. Yeah, it's USB-C.
We have a call to action.
All right.
The call to action is please stay awake.
Yeah.
It's the only call to action we have in this presentation.
That was interesting. All right.
From 50 to 0.
So, yeah, I'm like, it really, like you prepare everything, the VPN to this, and power. And now we have to reconnect. So as we do.
Oh, actually, it is reconnected. Awesome. Oh, it's going to take forever.
Yeah, now we have to load it again. So while you do that.
Chiron.
What?
Chiron's would be faster.
Yeah. Now we're gonna, but I need to go to my deck.
Oh, yeah, hang
So actually, we took the AI, and we also have been building it for a few months now. And the idea is to have a system that is fully integrated with the fabric. I mentioned network source of truth. One of the things that we are is the all-seeing eye. This one?
Yep. There you go.
So if we have time, we'll do back to Project Kilo demo. So we call our AI agent Sensei, master of its own craft for the Japanese culture lovers here. And from my perspective, from our perspective, our Gen AI Fabric QA is the AI tool. Humans are not enough to do this kind of scale to understand, troubleshoot. We have 8 GPUs. Yeah, you might be able to do it. If not, you need a little bit more sophisticated tool. I'll let Greg take it from here.
Can you hear me? Sound good? So the previous talk was perfect for take all that, and I'm going to try my best to not duplicate it. A couple things to answer some questions about the metrics. So our focus is on the high-level observability services. So the system needs to be able to let the network administrators know what's wrong and not just send an alert, send a notification, send a ticket. It needs to get to the point where it's fixing those things automatically. Before it can do it automatically, I don't trust it, number one. If I told my bank to go, I think we lost the power again.
Yeah.
I'll just talk. If I told my bank to go get, to take out $200 from my account, and it said, okay, I did it. And well, what if I accidentally put in 20 bucks or $2,000? I need a human in the middle before I go further. So our chatbot stops and does not do a single thing unless I tell it specifically, implement these changes that I have told you to do. First of all, it says, review these changes. And we saw that in the other demo. So these are great, this is great market information to know that this is how network administrators want to see. I want to see the changes. I want to see the request I gave you. But I don't want you to go do it automatically because I don't trust you because you're an AI and you're not doing the work specifically yet. Now, down the road, as we're checking, hey, it looks like you're always asking me to make this change. Do you want me to just the next time you ask me to make that change, just to go ahead and make that change? Maybe you'll say yes. Maybe you'll say no. But always make sure there's a human in the middle before we get there, because it's the network. It's not just something at a layer 7 and an application. It's the network. So the network has to be reliable. The AIs on a network have to be that much more reliable. The data has to be of truth. If everybody knows about temperatures of an LLM, that temperature's got to be almost at 0. Can't be hallucinating at all. So all of these things go into how do you make sure that your LLMs have almost no generative part to the LLM itself. And that goes where you have your data. One of the problems with us as the network administrators is time series data has no language. It's not a language. It's time series data. It's machine learning. It's not AI in that sense. So the ability to get that together is a great thing for the future of AI and machine learning, which is exciting. On top of that, because I do have an LLM though, and I have anomaly detection services, so I do have time series data, but I need to tie that to providing educational and information to the network administrators, either through a ticketing system or whatever. That's another place where a great LLM is going to be used. I also need to make sure that that's happening internally. I think the demo's still showing. I got to make sure that the information is being shared, and I can use an LLM to make sure that that's a very educational, it's not just an automated, hard-coded answer. It's based on a trained LLM and a knowledge base, and we saw knowledge bases in the last demo. So I'm going to show you really quickly. Can I go ahead?
Yeah.
Okay. So I'm going to go into Sensei, and I'm going to assume I am an electrician, not even a network engineer. I'm an electrician at a union, and I have to replace a fiber because I got a bad fiber cable. And part of my union, I get to replace fiber in the network. So now I want to make sure.
So you can use two hands.
So I want to make sure that everything's okay before I do that. So I want to replace, let's say, port 7 of leaf 01. Where's the leafs? There's leaf 01. Did I get that right? What is the impact? Can I just do it right now, or is it going to impact anything? So it's going to go off, as you saw in the previous demo. We're doing the same thing. It's going to go off. It's going to actually look to see what are the services associated with that port? What's the traffic? Is there anything on there? And if so, let me know about it. So it says, hey, you have 2 services. Here's the traffic. Don't just pull the plug because it's going to impact what's going on here. So it's like, okay, well, I'm going to misspell what. What else is available on leaf 01? So is there anything else that I can plug in when I take 7 off and I need another port? So it says, oh, there's 32 other available ports. Okay, I'm going to open up those reports that Luke showed you. And I have all these different ports here. So I'm going to look down. I'm going to say, okay, I'm going to take port 40 through 42. I'm going to make that happen. So I'm going to say, I'm not going to go into debug mode or whatever that is. So I'm going to say, I'm going to make port 40 to 42 on leaf 01 connected to service engineering. Let's see what that does. So what this is doing is it is going off to an LLM and coming back with prompt engineering, but it's also coming back and providing internal information in the, it's actually calling functions inside of our automated tools. So Luke's demo was going to show you hundreds, right? Mm-hmm. Hundreds of changes that the system does through it's all internal. So that's automation. So now we're taking AI and triggering those automations. So that's a perfect place for prompt engineering. So now I'm going to go in and I'm going to say, okay, provision port 40 to 42 for service biopharma. And so now that's going to go in, and it should go up and update the change set.
And you could see how it turns into this lime green. This for us in our language means that it's provisioning. So you can see he's hitting leaf 1, and as he adds the changes, you're in this screen.
Thank you. Okay. Okay. I'm going to say remove port 7 from biopharma service. And so I'm going through and I'm doing all these steps. So I'm just simply replacing things from the GUI and making sure that I'm just setting everything up correctly, and I'm removing things. And when I go in there and I do that, control.
So I want to leave some time for questions, so maybe some of the questions will be on this. But there are 3 steps we're going to take for AI. First is what you see, observability. The second one is going to be a proactive maintenance. And I think some of the things that Celestica asked earlier is like, where do we see this port flapping? Why do we see this temperature rising? Is it a problem with AC? Is it this? Why is it down? Why is that link down, switch down, whatever it is, show causality. The third will be autonomous networks. Those are networks that are truly self-optimized and there to protect themselves. The shocking number is humans take So network outages, unscheduled network outages, humans are in the cause for about 70%. So what we are trying to do here, especially in the large complex networks, is prevent that 70%. Prevent that by using advanced tools that are truly based on your data, based on your network source of truth. So
you saw how it turned purple there? And then it had to wait till actually it said implement those changes before those changes were set up and actually created those associated with those ports. And so now it's around 5 o'clock and we're all hungry, so where can I get, let's just say pizza in
San Jose?
Thank you. San Jose. This is a downtown town. Let's say if it goes anywhere. And unfortunately, it's not going to let me utilize our tokens to go answer general ChatGPT questions.
Yeah.
But hopefully that answered some questions for you guys and showed you how we are combining prompt engineering, LLMs, and automation together. Next steps is to fine-tune that, which we talked about, which you've seen before. Fine-tune it, bring it in locally so it's inside of a network, and have local LLMs. I'm just so happy that the open source community is doing 7B LLMs, because being able to provide a 7B LLM inside of a closed network is so much better than a 70B or whatever Llama 3 405 billion parameters is going to be like. I don't think we're going to need that. So that's where we're going now.
Yeah. Any questions? I know we got, I don't know if we...
I'm sorry, we somehow lost the microphone, so no questions.
Oh, yeah. We just need a new LLM to charge computers before we do presentations, so, yes, Taras.
The question is how efficient it is from financial point of view. Training LLM and running LLM is quite an expensive case that NVIDIA is happy about. If you are operator, is it more efficient from the financial point of view or not?
Once you get to the local LLM, then your inferencing is basically, you already, as long as you have that hardware already in place, and you're not pointing it anywhere else, you're not using anybody else's tokens, you're just pointing it straight at that local LLM.
That's our biggest challenge. It actually, also most of the carriers, most of the operators won't let you take that data outside. So actually, we have to run it locally. So right now, our solution is based on 2 virtual machines locally. That will be a 3rd virtual machine that will run on a dedicated hardware. There's some stuff that comes out with AMD. There's other things that you can run, decent size LLM, like, we're talking about 7B or maybe 70B, that you can run locally on a machine that'll be able to do that. But it has to run locally.
So NVIDIA didn't say this today, because they aren't here representing NVIDIA. But NVIDIA, in the keynotes at their presentation, they were showing how there's new LLM microservices that are coming out for local environments. So I'm really interested to see where that's going to go. They showed how Dell is going to be a major part of selling that whole environment. So it's really interesting to see how those new local LLMs that are really 70B LLMs now and inferencing, how that's going to change how we automate a lot more. Basically get AI to help us automate.
If I may follow up, how fast you can get data back to LLM to reflect the changes within the design, within the services? You need to retrain, or how you can rely on LLM, which was not being retrained yet?
It will constantly be retrained. So it's the part that was not in the presentation was the entire ML ops side of business. And not only detection I didn't mention, because how do I ensure that I'm smarter training anomalies in the future? I have to continually train it. So also behind the scenes, I have to make sure that the new models are smarter than the previous models. So there's testing in that as well. So there's a whole lot of ML ops that are involved behind the scenes.
First of all, it's Keysight, not Keystone.
Sorry. Yeah.
Not
enough coffee.
I wanted to find out more information about Project Kilo. Is there a GitHub, or is some open source materials that we can study and find more information about it, or is that beyinet.com?
It will be both, so we just announced it today, so we will do, one of our colleagues, Josh Saul, will put it on Git, but you can email us here and you'll be able to get it.
Oh, thanks.
And by the way, Taras, we don't have a database for the network. It's actually constantly live, so if you change things, if you do things, it's always like it's a network source of truth. So some things happen every 5 seconds, some will happen every few minutes, but it depends on your network. Yeah, obviously, if it's a project deployment this big, cannot happen everything every second because you're going to kill yourself. All right.
All right. Thank you.
Thank you so much.